In this series of videos, I'm going to walk you through pages 4 through 6 of this handout. We've already finished up the first 3 pages in class, so I'm not going to go back over that again. But we're going to start at this page right here. We've already talked about the parent functions for sine, cosine, and tangent. And so I'm going to start with these examples. And again, I got through some of these in some of the classes, but you might want to watch them again also. So this first set of problems, this first example, we are going to be combining transformations and specifically combining 2 verticals and then 2 horizontals. And then at the end, we'll put them all together. So the first example is if we have 2 vertical transformations. And when you have 2 vertical transformations, you do have to make sure you're doing them in the correct order, as we've already discussed. And so the first one, you'll notice that these are both outside transformations. So that makes them both vertical. And remember that when they're both vertical, we're changing the y values. And the x values are going to stay the same because there's nothing going on inside. So I've listed the y values over here, and we're going to do those transformations for that. So remember that the stretching and the reflecting comes first. And when you do that, we're going to multiply. Our scale factor is -2. And so that means we're going to first multiply the y values by -2. And so if I do that, I end up with -2, 0, and 2, +2. Then we have the +3, and so the next thing we're going to do is add 3 to those values. And so when I do that, -2 + 3 gives me 1, 0 + 3 gives me 3, 2 + 3 gives me 5. So those are our new y values. And notice that they're flipped. It used to be largest down to smallest. Now it's smallest up to largest because the -2 flipped those values. All right, so then what that means is, as far as doing a rough sketch of this new function, is that the x value stays the same. And notice up here I have the parent function for both sine and cosine, and the x values go from 0 to 2 pi, and they're basically the quadrantal angles. So we're going to put those in. So pi/2, and these do have to be labeled. And then the new y values are 1, 3, and 5. And I suppose I should have made my axis go a little bit lower. I think on the other answer key I did. So we've got 1, 3, and 5. And you don't have to worry about scale here. These are just sort of rough sketches, so it doesn't make any difference. So what that means is now sort of our new, and you don't have to draw these in. I'm going to try to do this very lightly here. Let's see how this marker works. So we end up with, it's too light. We end up with sort of our starting place right here for our function, for our period 1 over here. And then this is the bottom along here, and then this is the top. And then here's our principal axis. Our principal axis moved up. And so our graph is going to be entirely within that box. Just like over here, we sort of have the top and the bottom and the left and the right, and our function, our period, is entirely within that box. So inside of that box, then when we sketch this graph, we have to notice that the sine function hits this principal axis at the beginning, the middle, and the end. So that's what we're going to do here. We hit the principal axis at the beginning, the middle, and the end. And notice that at the quarter point, in other words, when we're 1/4 of the way over, we go high, except that this one has a flip. And so what we do instead is it flips over and it goes low. When we usually go to the 3/4 point, so 3/4 of the way across, it usually goes down, but again, because of the flip, this one's going to go up. And there is our sketch. Oops. And you can check this with your graphing calculator. Just go in and put this function in, and then put these window values in. Put your x min at 0, your x max at 2 pi, your y min at 1, and your y max at 5, and that will help you check it to make sure that it looks the same. As far as filling these values in, right, the amplitude, remember the amplitude is the distance from this principal axis, which is here, up to a high point. So from 3 up to 5 is 2, or it's also the distance from that principal axis down to the low point, which is 2. Or, remember, you can also think of it as half this total distance. So the total distance is 5 minus 1 divided by 2, and that turns out to be 4 divided by 2, which is 2. So that's the amplitude. What I want you to notice, because we're going to summarize this at the end, is that that value of 2 shows up right here in our function, almost. If I take the absolute value of negative 2, then that also gives me the amplitude. The period of this one, period, remember, is the horizontal distance that it takes to go through one cycle. That just stays 2 pi. That has not changed. But our principal axis did change. All right, our principal axis used to be at y equals 0. Now it's at y equals 3. And I want you to notice that that value corresponds to this value right here. Okay, and the reason for that is because the principal axis used to be here at y equals 0. When we did the multiplication, that didn't change it at all. But then when we did the addition, it took that principal axis that used to be here and it moved it up 3 units. Again, we're going to look at that pattern. For the next one, we're doing a cosine graph. And the cosine graph, the outside one is 1/2. And so the first thing we're going to do is multiply by 1/2. And then the second one is -4. So the next thing we're going to do is subtract 4. So the values we're going to get for this one are going to be 1/2, 0, and -1/2. And then when I subtract 4, 1/2 minus 4 is -3.5. 0 minus 4 is -4. -1/2 minus 4 is -4.5. So when I plot the points for this one, for the cosine, actually I'm going to, because those y values are all negative, I'm going to switch my x-axis up just a little bit. Remember that these values are going to stay the same because we haven't changed the x values at all. Now when I say the same, I mean the same as the parent function, which is right up here. So this is going to be 0. I'm going to write it above because my graph is below. Pi over 2, pi, 3 pi over 2, and 2 pi. And then on this axis, I need my -3.5, -4, and -4.5. So -3.5, -4, -4.5. Of course, -4.5 is smaller than -3.5. And then, once again, what we have here is we can say, well, this is still sort of the left of my graph. This is still the right of my graph. This is going to be the top. This is going to be the bottom. And then this is my principal axis right here. And again, you do not have to draw those. I'm just trying to outline them for you. You can draw them if you want. And now the cosine graph has a little bit different pattern. It starts up here at the high and it ends at the high. In the middle, it's at the low. And then at the quarter point and the 3/4 point, again, I mean quarter of the way across and 3/4 of the way across, it's going to hit that principal axis. So the cosine graph is going to start up here, end up here. In the middle, it's going to go down. And then a quarter of the way, it's going to hit the principal axis, and 3/4 of the way. And our graph, as you can see, is kind of a curve. So try to make it curved. What I usually think about is like an upside down parabola here. It's not the same as a parabola, but sort of parabola-ish. And then here, sort of a right side up parabola. And then here, sort of, again, an upside down parabola. So the amplitude of this one so remember, amplitude is, again, the distance from the principal axis to the low point, or the principal axis up to a high point. And hopefully you can see that that distance is 1/2, right? From 3.5 to 4 is 1/2. Remember, amplitude is always positive, and also notice that it matches this coefficient here. The period stayed 2 pi, but the new principal axis is -4. Right? We can see it right here, y equals -4. And again, the reason for that is because the old principal axis used to be here at y equals 0. That's this value right here. When we did the multiplier, it doesn't change it at all, so it stays there. But then when we do the -4, that pushes that principal axis that used to be here down 4 units. And so that number matches this. So down at the bottom, we're just going to summarize this. It says, note that for equations of the form a times the sine of x plus d, or a times the cosine of x plus d, which is the form that we have up here. They both have a multiplier, and then they both have a constant. Right? You can see that in the original problem, multiplier, constant, multiplier, constant. The amplitude turned out to be, now remember, the amplitude is related to a, but it's not exactly a. It's the absolute value of a, because amplitude is always positive. It's a distance. But if a is negative, then we can see that the graph is also going to be reflected over the x-axis. And that's what we saw in this first one. When A was negative, it got reflected. It first was reflected over the x-axis, and then it was moved. All right, and then for the last piece of this, it says, now note for the equations for any of these with the cosine, the sine, and then the tangent, as we'll see. The equation of the principal axis is going to just turn out to be y equals d. So that d tells us the principal axis. I'm going to stop here and do the tangent as a separate video.